The 1950s witnessed the rise of the first generation of portable anti-tank missiles. As a well-established military-industrial enterprise, Bofors naturally did not fall behind. The RB-53 anti-tank missile was developed in the late 1950s. This missile used relatively primitive technology and can be roughly divided into two parts. One part is the rectangular missile launch box and the internal missile, while the other part is the missile remote control device, connected by a 20-meter-long cable. The missile is normally stored directly in the launch box, which can be equipped with a shoulder strap for the soldier to carry it forward. The missile contains a small gyroscope, which is not electric but is rotated by gas during missile launch. The missile body has 4 folding wings which open after the missile flies out of the launch box, stabilizing the missile's rotation. When the missile is about 30 meters away from the launch box, the gyroscope unlocks, allowing the operator to control the missile's flight. The missile is first propelled by a booster rocket to a speed of about 85 meters per second. The missile itself is wire-guided, with the wire divided into 2 parts. The first part of the wire is only tens of meters long and ignites the main engine when released to 40 meters, after which the booster rocket is exhausted. The second part of the wire, released at 230 meters, when the missile has flown about 300 meters, puts the missile's warhead into combat mode. In other words, the missile's minimum range is 300 meters, within which the missile's warhead does not function properly. The control section connected to the launch box uses visual targeting, manual operation, and wire transmission of commands. The commands from the control stick are transmitted to the missile via a wire, then amplified through a transistor circuit and used to adjust the missile's flight attitude through the flow control at the rear of the missile. To allow the shooter to better observe the missile's flight direction, the main engine of the missile also ignites 4 tracer tubes. The missile's warhead uses a piezoelectric fuse, and the shaped charge warhead has a penetration capability of 500 millimeters. From the perspective of armor penetration, this is already very good. The missile has a maximum range of 2,000 meters. The Swedish side claims that this missile has a very high hit rate, reaching 95% to 98% within the range of 800 to 2,000 meters. For a visually targeted anti-tank missile, such a hit rate seems a bit exaggerated, perhaps based on data obtained from testing on stationary targets. The RB-53 anti-tank missile entered service in the early 1960s and is simple to operate. When soldiers use it, they first open the support bracket of the launch box, roughly align the launch box with the target direction, then connect the wire and deploy the control equipment, a process that takes only about half a minute. In addition to infantry use, the missile was also mounted on the Haflinger Light 4-wheel multipurpose vehicle, used as a mobile anti-tank missile launch vehicle. In 1965, there was an attempt to mount the RB-53 missile on the HKP-3 helicopter, although modifications were made to the warhead, with Bofors claiming that its warhead could penetrate 400 millimeters of steel armor. In addition, the Saab Mi-17 fixed-wing light aircraft also underwent related mounting experiments. In 1965, Sweden sold the RB-53 anti-tank missile to Switzerland, which used it until 1994. Argentina also purchased a portion of these missiles. The RB-53 anti-tank missile system weighs 20 kilograms in total, with the missile and launch box weighing 13 kilograms and the missile itself weighing 7.5 kilograms. The missile has a diameter of 110 millimeters, a length of 850 millimeters, a wingspan of 400 millimeters, a flight speed of about 85 meters per second, a range of 300 to 2,000 meters, and a maximum flight time of about 24 seconds at maximum range.